Hello and welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and Suna Withers joins me. We are broadcasting live from the Allan Carswell Observatory, located at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time at York U Observatory. We also run in concert with our online public viewing feed, or as we call it, the OPV, which is operated by the observatory staff. We always show some archival images, but if the domes are open tonight, we'll also have some live images to share. To navigate to our live show or learn more about us, please visit our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. If you have any questions or comments about past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Instagram at the handle at York Observatory or on Facebook at Allan I. Carswell. Our programs are free, but we would appreciate any donations you may wish to make. Please visit our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. Our theme for today is the dog days of summer. Looking outside my window right now, I can see clear skies, perhaps a bit hazy, but much of the smoke from forest fires has cleared. We are just past the full moon, so the skies should be dark after dusk for about an hour or so. How about you, Suna? How are you doing tonight? And are the domes open this evening?
I'm doing pretty well. We've had a couple of pretty good nights of observing in. I was here all night for the past 2 nights observing, so hopefully we can sort of push that luck a little bit more tonight to get in some more observing. But we do have a planned schedule for some observing for the OPV tonight, and it looks like we'll be able to open the dome. So keep an eye out for that in the OPV chat.
Yeah, when I see it come up on my screen, I usually try to point out what we're looking at and whatnot. But it's always exciting when as beautiful as the archival images are, it's always exciting when we've got some live image feeds as well.
Yeah, it's definitely exciting, especially with the telescope like the 1 meter. You can get some pretty cool images.
Yeah, absolutely, absolutely. Um, so we're going to start off with this week in space astronomy history, and soon I think you've got a deep space story to tell us about.
Yes, I do. So this is a bit of a scary one, which happened on August 16th, 1989, when the Earth got hit with a powerful solar flare, leading to Toronto's stock market being shut down for around 3 hours. Now, just a bit of context for this. The sun goes through an 11-year long period called the solar cycle, where its activity sort of peaks and then starts to decrease until it reaches a minimum and then goes back, starts climbing again until you reach a solar maximum. So the entire cycle takes up around 11 years. And it can lead to some kind of interesting activity, particularly around solar maximum. Now, when I say activity, I'm specifically referring to magnetic activity on the sun. So things like sunspots, coronal mass ejections, or solar flares, where the sun actually ejects charged particles out into space. Things like that all depend on the amount of magnetic activity that's happening within the sun. And when you go to times with peak magnetic activity, you start to get a lot more of these things. So solar maximum is really great for doing things like observing sunspots or seeing aurora. I'm sure you remember last year we had a whole lot of aurora, even as far south as Toronto. There was one night in particular where we could even see the aurora from York University and from the campus here. I think even some people were able to see some closer to downtown Toronto as well. And that was a result of us being in solar maximum for this solar cycle. So it can have a lot of really fun and awesome kinds of activity that we can actually see from the Earth. But on the flip side, these different types of solar activities can also cause some problems for humanity, in particular because they can do things like induce currents in circuits. They can also do things like cause radio and communications blackouts and damage power grids. So overall, while a lot of these activities and things can be really fun to see, they can also be kind of problematic at the same time as well. And this is something that happened back in 1989, where the sun was at or near the peak or the peak activity or solar maximum for solar cycle 22, which is the 22nd solar cycle since they first started being recorded in 1755. In 1989, near solar maximum, there was a pretty strong geomagnetic storm, which just kind of describes the areas or the times of really peak activity where you have tons of activity and things like solar flares and coronal mass ejections coming out of the sun. And it ended up wreaking a little bit of havoc on a couple of different things for a couple of different ways on the Earth. One of the pretty negative things that it did was it actually caused a mass power outage in Quebec, which ended up lasting for about 9 hours after it tripped a bunch of circuit breakers in Quebec's power grid. It also did something cool, which was give us some very strong aurora that reached as far south as Texas, which is honestly pretty unheard of. Texas is very far south, and the aurora typically tend to be concentrated kind of around the poles. So it's pretty rare to see something like aurora all the way in Texas, but we were actually able to see aurora in Texas in 1989 because of the sun being near solar maximum. But a little bit closer to home, on August 16th, 1989, we got hit with what's called an X20 class solar flare that shut down the Toronto stock market for a few hours. Now, let me explain what I mean by an X20 class flare. So astronomers have something similar to the Richter scale that's used to measure earthquakes on Earth. There's a very similar scale to measure the strength of solar flares, where the sun ejects charged particles off of its surface, kind of out into space, sometimes towards planets. The weakest is called a B-class solar flare, and then the next category is 10 times stronger than B-class. It's called C-class. And then you kind of go on until eventually you reach the strongest class of solar flare, which is the X class of solar flare. So for context, something like a C class flare, which is the second weakest category, wouldn't really be noticed on Earth. But when you start to get into these M class flares, they can do things like cause radio blackouts and start to interfere with different sorts of electronics or satellites, for example. Each one of these classes is also defined into a certain number of subclasses, which is where the number comes from in X20. So an X20 solar flare is not only in the highest class of solar flares in general, but the number actually puts it pretty high up on the scale in general. The strongest solar flare that's ever been observed was in 2003, ranking as an X45 solar flare. So X20 is still a very, very strong solar flare, and it can do some pretty serious damage, not even just limited to blackouts, but it can also do things like interfere with power grids, and in this case, interfere with the Toronto Stock Exchange. So what happened in the stock exchange in particular is that it caused they had 3 disk drives that helped keep the stock market online. It caused all 3 of those disk drives to fail by inducing currents in some of their microchips. This was a really shocking event at the time because these 3 disk drives were supposed to be completely redundant. They were kind of designed in a way that you wouldn't have 3 of them failing all at the same time. So if 1 or 2 of them had problems, you would still be okay. Not everything would be shut down. But it was very, very shocking for all 3 of them to all of a sudden go offline at the exact same time. And it turns out that that was caused by this very strong class X20 solar flare from the sun. So just, I guess, a happy anniversary to this crazy event where the sun is interfering with a whole bunch of stuff that we're doing on Earth, to August 16th, 1989. And as a result of the solar activities in and around 1989 associated with the solar flare, there were a whole bunch of changes made to things like the Toronto stock market for a period of time, and also even to how Quebec hydro systems were set up so that they wouldn't fail all of a sudden in the event of another sort of strong solar flare.
So this is interesting because I actually have a once removed personal connection to this event. About about 12 or 13 years before this, I was a teenager and I was working at the or I was going regularly every Saturday to the McLaughlin Planetarium in downtown Toronto, and they had at the basement the RASC, the Royal Astronomical Society of Canada, had what they called the optical workshop, and we would go in and we'd grind mirrors for telescopes and things like that. It was a lot of fun. Uh, and I would go religiously, and it was every Saturday and I think every Tuesday night. And one Tuesday night, a couple of people came in and they had a school telescope they were trying to salvage, and we talked and gave them some advice and so on. But I became very close friends with one of those people that came in from this high school, and so let's go forward. Many years later, I've studied engineering and he has studied computer science. And he is working in the data center at the Toronto Stock Exchange when this happened. And,
Oh.
it, and he called me a couple of days later and said, I never thought astronomy would affect my work.
I mean, one of the things
So,
I'm wondering is how long did it take them to figure out that it was a solar flare that did that? Because even knowing and having the background about, we're in solar maximum, the sun can do things to interfere with electronics. If a bunch of my electronics started to fail, I probably wouldn't think right off the bat, oh, it's the sun. So I wonder
no,
how long it
they,
took them to figure
yeah,
that.
they, yeah, they didn't figure it out. Basically, Environment Canada figured it out. Like the Canadian government figured it out and told them
Oh,
because Quebec was affected and so on. But they just knew they had the oddest failure. They had a primitive RAID, which is what they call the arrayed disks system. Pretty primitive. They became a lot more sophisticated generally following this. But they were told eventually by I think Environment Canada. So yeah, John, if you're listening, um, the story reminds me of the days. So, so, um, but this is my story. I guess is it's simultaneously of this week in space history and its news. So on August 7th of this year, so last week, astronaut Jim Lowell died at the age of 97. Now, to say that Lowell was extraordinary, even among a fantastic group of people such as the Astronaut Corps, would be no understatement. He was born in 1928 in Cleveland, Ohio, and he had Canadian and Czech parents. His father was from Toronto. He graduated from the U.S. Naval Academy in Annapolis in 1952. And then in 1958, he graduated from the top of his class from the Naval Test Center. He narrowly missed entry as one of the Mercury 7 astronauts due to a slightly off medical reading, but he was accepted as part of the next nine in 1962. And other people in that group were Neil Armstrong, and if you follow the space program, a couple of other legends by the name of Pete Conrad, John Young, and Frank Borman. He was originally designated to serve as the backup pilot for Gemini 4, which meant because he was backup, he'd have the same role in a primary capacity 3 missions later. That's how they did it. That was Gemini 7. Now, Gemini 7 had two primary tasks. One was to orbit for a long time, 2 weeks, and the other one was and this was a late addition to the plan, to rendezvous with Gemini 6. Gemini was all about testing the individual elements which would be needed for the lunar program in Apollo. And with any planned scenario, 2 weeks was considered as long as the Apollo mission could go. And it's important to realize how difficult Gemini 7 would be. The rendezvous itself was a huge challenge because they'd never done it before with two-man spacecraft, but the long duration aspect was unspeakable. The rendezvous started with, and when, sorry, the rendezvous was added. So the original plan was for Gemini 6 to launch after what was called an Agena target vehicle was sent into orbit. But that vehicle exploded. So mission planners quickly said, we'll launch Gemini 7 first. It can do its 2-week mission. And then towards the end of it, we'll launch Gemini 6 and they can rendezvous. Now, you need to understand how small the Gemini capsule was. It was tiny. And try to imagine two grown men in an area slightly larger than a phone booth. And for any of our listeners who've never seen a phone booth, and they exist now, think of a small walk-in closet for 2 weeks with no bathroom. And for this mission, he was paired with Frank Borman, one of his classmates in the Next 9. So Gemini 7 was launched first on December 4th, 1965, and Gemini 6, now called 6A because of the change to mission profile, was launched on December 12th. And the two met on the 15th, and they launched. There was an aborted launch on the 12th. Sorry, I mean this wrong. And it was launched on the 15th. The two spacecraft flew in tandem to 3 orbits, the distance between them varying between 30 centimeters, like 0.3 meters, and 90 meters. So if you use imperial, between 1 foot and 300 feet. 6A returned to Earth on December 16th. Now, the Gemini missions were kind of famous for the slow cascade failures. So as the mission got longer and longer, more things would fail. But they were able to get through to the end. And they completed their mission on December 18th after completing 206 orbits of the Earth. So then Lowell commanded the 4-day Gemini 12 mission, which was the last of the program, which focused on docking and spacewalk techniques, and Buzz Aldrin was his pilot. Everyone knows the name Buzz Aldrin. Lowell's next big mission is one for the books. It was Apollo 8. The CIA had received intelligence that the Soviets were planning a manned mission to circle the moon and return to Earth. NASA had tested the Apollo spacecraft, but not any of the technique necessary to navigate to the moon. And the landing system was not ready for launch, so they repurposed Apollo 8 to become a lunar orbit mission, hopefully leapfrogging the Soviets. Lowell, along again with Borman and lunar module pilot William Anders, lifted off on December 21st, 1968, and it began a journey that no human had ever attempted. They orbited the Earth once, executed a translunar injection burn, and put them on track to the moon. Lowell acted as navigator, backing up the computers at NASA. He used a sextant to measure the angle between either the moon's horizon or the Earth's horizon and a designated star. At about 56 hours after launch, Apollo 8 left Earth's gravitational influence and entered the moon's gravitational influence. Then at 68 hours, behind the moon, cut off from communication with Earth, the crew fired their engine to get captured into an initial orbit of 193 by 70 kilometers. And then that was later circularized to 70 by 71 kilometers. It was around this time the first picture of Earthrise ever taken by humans was taken by Anders. On Christmas Eve, the crew broadcast a message to Earth and then fired their engines and safely returned home on the 27th. The mission was a huge event all over the world. They were the first humans to leave Earth orbit, to cross the Van Allen radiation belts, to orbit the moon, to see the far side of the moon, to navigate between two space bodies, and splash down coming from an orbital escape velocity. It is also believed, and this was certainly documented in a couple of books, that Lowell was offered Aldrin's seat on Apollo 11, as Aldrin was sometimes felt to be difficult to work with. But whether true or not, Lowell didn't accept and was the commander of Apollo 13. And we've talked about Apollo 13 before, and you should certainly check out the movie or read the book Lost Moon. But it was the successful failure in which the service module exploded on the way to the moon, and the astronauts had to limp back on a damaged spacecraft, but successfully landed. And then after that, Lowell, and who could blame him, retired. but he'd spent a total of 29 days, 19 hours, and 5 minutes in space. And after retirement, he worked for a number of companies, founded a restaurant, wrote books, acted in films, and generally lived a very good life. He was predeceased by his wife of 71 years in 2023 and died, as I said earlier, last week.
That's a really, really remarkable career that he had.
It
That's,
is,
yeah.
yeah. It's, I mean, you think about what that man accomplished, and all the things that he did, and he held the U.S. Long duration space flight record, I think, until the second Skylab mission. The Soviets got ahead of it uh, because they were focused on the Soyuz missions, which caused them to focus more on long duration missions. But ultimately, they, he set the record. And I think what we would have to say is that, we've lost a legend. Now, he didn't walk on the moon, but he was, I think, the only man to go to the moon twice and not walk on it. So I think that he has to be celebrated. And we've only got I think five moonwalkers left.
Hmm.
So you have to say that the number of people that have had this experience is diminishing, and in theory, Americans and one Canadian are going back to the moon next year.
Yeah,
So
in
yeah,
theory.
yeah. So yeah, so Suna, we're running a bit early, so I think we were when we were editing the show last minute. You had one more news item. I think we've got the time to do that one. Maybe on the I think it's the Mars Reconnaissance Orbiter.
Sorry about that. Yeah, it is the Mars Reconnaissance Orbiter. I mean, it's funny that the one time we are going, we're early. I don't think this has ever happened before, at least. Yeah, so it's the anniversary of the launch of the Mars Reconnaissance Orbiter on, I am not seeing the date here. Sorry, just give me 1 second to find the date. It's August 12th, on August 12th, 2005. Now, the Mars Reconnaissance Orbiter was launched as part of NASA's Mars Exploration Science Goals project, which basically just outlines four main science goals surrounding Mars exploration. These generally have to do with things like determining whether or not there was ever life on Mars or ever could have been life on Mars. Also doing things like characterizing its climate and geology, including any sort of water patterns or the presence of water on Mars, and with the final goal of eventually preparing for human exploration of Mars and trying to assess the feasibility of that human exploration. So the Mars Reconnaissance Orbiter itself, after its launch, it took around 7 months or so to get to Mars, and then ended up spending another 6 months getting into the correct orbit to actually be able to do science. I was a little surprised reading that it took 6 months to actually put it into the correct orbit, because I'm not sure if you could shed a bit more light on this, Paul, but I did not realize that sometimes it took 6 months to get into the correct orbit for this. But either way, it was very much worth it. The Mars Reconnaissance Orbiter has been doing a ton of really cool science and taking beautiful, beautiful pictures of the surface of Mars ever since it started doing science. But mainly what the Mars Reconnaissance Orbiter has been doing is kind of studying the Martian climate and climate change, which include monitoring things like dust storms. It's also been looking at the not only the current water content on Mars, but it's also been learning a lot more about the past water dynamics and the way that water was able to move across the red planet over time. And then finally has also been helping to kind of scout out future landing sites for potentially future landers on Mars, but also, I don't know, maybe at some point it might be useful for potential human landings on Mars. So it's kind of been doing a whole bunch of different really interesting things when it comes to studying Mars. Now, kind
Yeah.
of overall, sorry.
No, I was going to say, yeah, it's a remarkable mission in the sense that, first of all, it's now into its third or fourth extended mission. You asked the question about why it took 6 months to circularize its orbit. Um, the challenge with getting a spacecraft, a big spacecraft like that, to Mars is fuel to slow down. So they take enough fuel to get it into a really strange orbit. And then what the MRO did, the Mars Reconnaissance Orbiter did, was it started dipping into the Martian atmosphere and doing using its solar panels to aerobrake to circularize its orbit. But it was a very gradual process. It took 6 months.
Okay, okay, that makes sense. That's really interesting. But yeah, sort of I won't take too much time so we don't end up going over time, but the sort of general picture that the MRO has painted of Mars is that it's actually a very, very diverse and like constantly changing planet. It might not necessarily look like it because Mars does not, it's kind of dry now, but it turns out that Mars in the past was wet. It had a period where there was a lot of water on Mars, and then it went through several long periods of ice ages until it's eventually ended up changing and turning into the kind of dry red planet that we see today. And it really was this history of ice and these ice ages that the MRO really helped to reveal. Because prior to the MRO, we didn't really think that there was that long of an ice age on Mars, or we didn't really know too much about that transition period when Mars went from being a primarily wet world to a primarily dry world that it is today. So the MRO has done a whole lot of work in revealing kind of this middle age on Mars, where you can learn a whole lot about the history of the ice ages on Mars and the way that water has sort of moved over the surface of Mars from the ice caps all the way to sort of the mid-latitude ices on Mars. One thing I also want to point out is that was, at least at the time, was the highest resolution camera that had ever been put on a Mars orbiter. The pictures that this thing takes are absolutely fantastic. It's honestly hard to believe that some of these are of Mars. They just look so fabulous. So if you do have time, definitely go and look up some of these MRO images of the surface of Mars. They're absolutely gorgeous, and it's actually able to over time map out the way that some of these surface features are changing, because Mars still is actually a very dynamic place that is changing over time. This is partly due to things like wind patterns and everything on Mars, where these wind patterns can do things like shape the sand dunes, for example. So the MRO is absolutely amazing orbiter, absolutely amazing satellite, and happy launch anniversary to the MRO. And before I forget, we are actually live on Sky with the 1 meter. We are currently looking at Polaris, where you can see Polaris A and B, including that faint little companion star in the Polaris system.
The North Star, yes,
Yes.
absolutely. I will add one further comment about, and it's going to tie into another story we're going to do in a bit about the MRO. As you said, it's got a fabulous optical system, including a really big telescope for a spacecraft. So Comet Atlas 3I is not coming particularly close to Earth, but it's coming quite close to Mars. And the plan is to take the MRO, turn it around, and when it's at closest approach to Mars, photograph 3I Atlas with that camera.
That
So that's amazing.
Yeah, that has to be some kind of record. Like, has anybody ever done that before with
Uh,
satellite?
yeah, they have, but it's not with a comet. But Cassini was famous for taking pictures of Earth and the Moon
Mhm.
from Saturn, and I think a couple of other spacecraft. I'd have to double check. Have done things similarly, like taking pictures of transits are very popular, like Venus transits and whatnot, or Earth. I think Earth transits have been captured on Mars as well. I'm not
Yeah,
sure about that. So.
yeah.
But But just time to get into our reminders here. You are listening to York Universe. We broadcast live from the Allan I. Carswell Observatory at York University in Toronto, Ontario, Canada. Please look at our website, yorku.ca/science/observatory to join the chat. If you have questions or want to see some of our content, you're listening to Suna Withers and me, Paul Mackin. We've been discussing some historical items. If you're interested in our online public viewing, please navigate to our website and follow the links to join in that fun. And as I said, as Suna said, we've got the domes open and we are observing. We do have a couple of reminders before we get into some news items for this week. As in most weeks, we're hosting an event at York University. This week it'll be the Atrium Observing event on the 5th floor of the Arboretum parking lot at Keele campus on Wednesday. This is a great opportunity to come out and look at through a number of telescopes and see live what is going on in the night sky. It's absolutely free, although you do have to pay for parking, but you can get there by public transit as well. So tickets are free. You can find a link on the website to get them. Of course, donations are always welcome. On alternate weeks during the spring and summer, we host observatory tours at the Allan I. Carswell Observatory on the 4th floor of the Petrie Building at the same Keele campus. Tickets for that are also available through our website. And, come out. It's a lot of fun. And summer's, as we'll talk a little later, summer's a great time to do some astronomy. So now, a bit of a special event. We're going to be joined by Professor Robin Metcalf, who wants to tell us about an initiative she's involved with, which might interest some of our listeners. Are you there, Robin?
I am. Hi, Paul and Suna. It's great to chat with you. Really good
Lovely
show
to have
so
you.
far. And I've really been enjoying the view for the telescope as well. It's very cool.
So tell us about Launch Canada Challenge.
Sure, yeah, thanks. So next week, I'm going to be hauling myself up to deep northern Ontario, as far north as I have ever been, where I will be volunteering at the most mind-blowing event going on in this country right now. And that is the Launch Canada Challenge. It's an annual event. It's now in its 4th year. And what will be happening is 30 teams of university and some high school students from across Canada. So there's going to be over 1,500 students altogether. They will be competing against each other to see which team has designed the best, most advanced rocket. And by rockets, some of these are as big as like multi-staged beasts, like up to 12 feet tall, aiming for heights of up to tens of thousands of feet. There's going to be 100 high-powered launches altogether and about 50 mid-power launches, showcasing the incredible ingenuity and resourcefulness and team problem solving of the very best of Canadian aerospace engineering talent. And the goal of all this is to create career pathways for these students so that Canada can play a significant role in the future of aerospace and have a voice at that global table. So I am ridiculously excited to be helping out at this event for my first time. I'm going to be joining the media and communications team. We're going to be taking photos and collecting stories from the event so that we can share this adventure with the world. And if this sounds like something you'd like to hear more about, which it should, if you have a pulse, then you'll want to head over to launchcanada.org, or you can just go directly to the Launch Canada social pages on YouTube and X, Instagram. You'll find coverage of this year's event. There's going to be a live stream, and you'll also find coverage of the event from previous years as well. Sorry, if I can just take one more second just to highlight a couple of teams that I'm particularly excited about. There's a team that originated from York's Lassonde School of Engineering. It's now called Arbalest Rocketry. They're going to be launching a 2-stage rocket known as the Goose 4.1. And this is super cool. There is the Bishop Strawn Rocketry team. Bishop Strawn is an all-girls high school in downtown Toronto. and they are returning to Launch Canada for their second time, and they're going to be launching a single-stage rocket aiming for 17,000 feet.
That is amazing.
Isn't
I'm
it?
familiar. Yeah, I actually met with the folks from Lassonde. They're very determined and they're a fun group.
Aha.
They were telling me that their goal is to get to about 30,000 feet.
Mhm.
But that's on two stages, as you said. But I'm fascinated by they try to entice me to get involved a little bit, and I'd be happy to do so. But then they mentioned going up there and how they actually, once they launch the rockets, how they retrieve them. And at that point, I got really nervous. So maybe you could tell us about that.
Yeah, well, so the teams have to submit their predicted trajectory and recovery location. And then during the actual launch, they track the landing site as best as they can with GPS. And then they hike through the woods trying to find their rocket. And when hopefully they do, they then have to submit a post-mortem report in which they compare the actual recovery point with their prediction. They also have to take photos of the recovery and to show any damage to the rocket and that sort of thing.
Now this
I'm
is Northern Ontario. There is nothing there but forest. I mean, there's some
mhm.
roads and there's Timmins, lovely
The
town.
roads are apparently not what we think of as roads.
They're not.
And
I know. I've been
riddled,
there. It's
yes.
incredibly.
Ah,
It's
cool.
rustic. It's rustic.
Rustic, riddled with wildlife, I hear. Um, yeah, forest fires, as far as that goes, so according to Ontario's Ministry of Natural Resources, the Launch region has a low forest fire danger ranking. And that just means if a fire starts, that it's unlikely to spread, so it's more likely to self-extinguish. Um, Non-zero, though, possibility of fires. I have not yet learned how the group plans to manage that risk. I'm going to ask about it just for my own curiosity. All I can say at this point is that at every meeting that I've attended so far, I have been blown away by the organizational skills of the executive team. They are on top of every possible detail, from launch safety to like the Tim Hortons runs to porta potties. So I have no doubt whatsoever that they have very detailed plans in place for dealing with any fires. I feel quite safe with this group.
Absolutely. Wildlife for sure. Bears would be the riskiest thing you've got there. The bears don't worry me too much. The smaller they are, that worries me. I hate insects, and it's bug
Ah,
city up there. So take your bug
yeah,
spray. Take your bug spray.
absolutely. Yeah. I'm
Well,
not
this is
enjoying that,
yeah.
looking forward to that aspect of it. It's very remote. It's not an easy trip. And it is really amazing that these students are, they have this dedication to put themselves through this. It's hard to get up there. Many of the students are camping, and it's not like this is provincial park camping. There's no comfort stations. Yeah, this is really, it's hard, and it's a lot of teamwork, and it's really impressive. And then there's just like getting all their stuff there, getting the rockets there and the equipment and everything that they need, right? Like it is really an incredible problem solving real world experience.
I met them, as I said, the York team, and they were some of the most impressive young people I've ever come
Yes,
across. It's
all the more
just
reason to get this event out to the world and showcase
absolutely.
these incredibly talented people.
Well, perhaps when you come back, we can interview you again, and you could tell us about the experience. I think would really be a lot of fun.
Oh, I'd love it. That'd be so fun.
Okay, super. So, thank you, Professor Metcalf. I guess, we're moving on in our time. We are observing live. Suna, do you know what we're observing right now? I
Yeah,
can't.
we're on Messier 71 right now, which is an open
Okay,
cluster, and it looks like
got it.
going to the next target in a second as well. But thank
Okay,
you
super.
for joining us, Professor Metcalf. That was really interesting to hear about. I wasn't aware that there were competitions like that near here.
Me neither. And sorry to interrupt, but it's funny because I knew nothing about it until a few weeks ago when a student in my Nats class on spaceflight and space exploration, she just mentioned it to me out of nowhere. And I looked it up and I was like, I am so in. So
Yeah.
yeah, not enough people know about it. It really is an incredible, incredible initiative.
Yeah, it sounds amazing.
You know,
Have
this is one of the funny things I've found since I've come back to university as a mature student. There's so many good things, so many noble things and fun things to get involved with. You know, there it's just it's so exciting, and I'm really glad you're helping them out because uh, you know they deserve all the support they need. And I'm not just talking about the York team. I'm talking about all these kids. I mean, Bishop Strong School is a high school. You know, kids, girls 14 to 17, and they're doing this.
That is
It's incredible.
incredible.
It
Yeah,
is
I can't wait
incredible.
to meet them.
Yeah, it's super. Okay, so I guess it's time for some items in the news. Suna, I'm going to turn this over to you. This is definitely as soon as I see the letters JWST, I'm thinking Suna. So
Yeah.
I will turn this over to you.
Yeah. So this is yet another interesting discovery out of JWST. It's been doing a lot of work in identifying some of the earliest galaxies and earliest objects to exist in our universe, which was really one of the things that it was built to do, is to just get a better understanding of how early galaxies are formed and evolve, and also the way that black holes in galaxies are actually able to interact with their host galaxies. So something that was discovered by the Hubble Space Telescope quite a long time ago is that all massive galaxies have these supermassive black holes at their centers that can be things like a few 100,000 to even a few 100 million times the mass of our sun. So really massive black holes in the middle of massive galaxies. But it's one of the fundamental questions surrounding this is basically the problem of the chicken and the egg. What came first? Was it the chicken or was it the egg that came first? And that's the same thing that you can ask about galaxies and their black holes. Is there's a whole lot of uncertainty about if it's the black hole that comes first and then the galaxy, or if it's the galaxy and then the black hole, and kind of how they co-evolve and interact with each other over time. So one of the cool things that JWST has been doing is studying and observing black holes that exist in the early universe. And it's recently just broken its own record and discovered the most distant black hole that we know of in our universe. This one in particular is in the middle of a galaxy called Capers-LRD-Z9. The name probably sounds like complete gibberish, but it does actually make some kind of sense if you just give me a second to explain it. But basically, this galaxy exists when the universe was only around 500 million years old, which is about 3% of its current age. So this is really one of the most distant, or among the most distant objects to exist in our universe. So this object, the name for the object has a couple of different important parts to it. First of all, I can explain the name Capers. Capers is just the name of the JWST observation that found it, which was a program that was designed to basically observe very distant galaxies in the early universe and start to understand their dynamics, which includes the way that the black holes in galaxies interact with the galaxy itself, and kind of observing the properties of these black holes. The Z9 at the end of the name is just a term for redshift, meaning that it's at redshift 9. That's just another way of saying that it exists when the universe was only 500 million years old. And then finally, the other interesting part of this name is the LRD, which stands for little red dot. Now, LRDs have been kind of confusing everybody for a couple of years now. Ever since JWST released its very first observations, astronomers started finding what are literally just little red dots in these images. They're really, really tiny things that don't appear to have any structure to them. They're very red, and they're also very, very bright. So typically, to get an object that looks like these little red dots, or LRDs for short, you basically have to have a whole bunch of very bright stars. So what you would usually think is that, okay, these galaxies are really, really massive and they just have a whole whack of stars. And while this works perfectly fine for objects that exist later in the history of the universe, this doesn't really work very well for objects that exist when the universe was only 500 million years old. because in total, it's only had 500 million years to build up this mass and create all of these stars. And it turns out that objects just cannot get that massive that fast. So these things have been very mysterious, and astronomers are not entirely sure where they come from, which earned them the nickname of universe breakers early on in the early days of JWST, where nobody really understood exactly what was happening here. Now, at this point in time, there has been quite a bit of research into what exactly is going on in LRDs. I don't really think many people call them universe breakers anymore, because we do seem to understand now that most of the light that is produced in these galaxies doesn't actually come from stars the way we might normally think of it, but it comes from the stuff surrounding a black hole. Now, the black hole itself can't actually emit any light, so you're not seeing directly the black hole, but what you're seeing is the influence that this black hole has on the matter that surrounds it. So if you imagine taking a black hole and you put it kind of somewhere where there's a whole bunch of gas and stars and dust and everything, a lot of this stuff is going to start to orbit the black hole and potentially even start to fall into the black hole. And when it's in this process, a whole bunch of really interesting stuff starts to happen, primarily that all of that stuff, which is part of what we call an accretion disk, starts to get very hot and heat up and get super, super bright, which makes black holes some of the most luminous objects in the universe, just because of the really extreme things that are happening. So there's been more and more evidence to suggest that LRDs are actually just young, growing black holes that are kind of cocooned in these really dense areas of gas, which is what's giving them these really wacky brightnesses and these really wacky properties that were kind of confusing everybody for a while. So there's still a whole lot of things to be learned about LRDs, but it's kind of starting to look like the black hole interpretation of LRDs is probably the correct answer to this, which is where this object comes into play, because it is a little red dot existing when the universe was only 500 million years old. So it's a pretty extreme, pretty rare object. And the team in this case ended up doing spectroscopy of this galaxy to understand more about the black hole and also the way that it's influencing the matter that surrounds it. So in particular, what they were able to do with this black hole is not only confirm that it actually exists, which was something pretty important they needed to do. You can't always tell when you're just looking at the images. You really need to do the spectroscopy to be able to tell for sure what exactly an object is. So not only did they confirm that this galaxy does have a supermassive black hole at the center, but they were also able to show that it weighs around 300 million times the mass of the sun. So just to put it into perspective, this is a really massive object. It's about half of the mass of the other stuff and the other stars in the galaxy. So it's really kind of dominating the galaxy even in general, and is doing a whole lot about regarding influencing the gas and the galaxy that surrounds it. So objects like this are incredibly interesting, not only because they tell us more about little red dots, but they can also help us understand a bit more about how these black holes form, how they evolve, and how they interact with their galaxies. So just based off of the observation of this particular black hole and its galaxy, it's looking like black holes in the early universe either grow a lot faster than we previously believed, or they just actually began their lives and started their lives as black holes as much more massive than models and theories suggest at the moment. So it's definitely sort of opened up a couple of more questions surrounding early black holes and how they evolve, which is a pretty interesting object.
You had me at 300 million solar masses. That's the thing about the supermassive black holes. The numbers, we think of the sun, it's the largest object in the solar system. It's a big thing. But on the scale of the universe, it's not very big and it's not very extraordinary. And there are objects out there, even active stars, that just dwarf it. And then you get into supermassive black holes, and we're talking a totally different experience. It's incredible. It's incredible.
Yeah, in astronomy, you very quickly reach the point where like every single number you quote is just completely incomprehensible. So I
Yeah.
know when people ask me like, how far away is this star? I can give them a number in like kilometers or light years or something, but it's just like at a certain point, it's kind of all gibberish is maybe the right word because we have no possible way of understanding how massive these things are and how far away they are. Um, so astronomy is kind of funny that way.
Yeah, and it's all about, scale, right? Like you could use for local things, you can use, kilometers or meters or whatever. You get out into space, then you might be measuring, tens of kilometers or hundreds of kilometers per second as velocity. But then you start to need light years, and then light years don't work anymore. So you need parsecs, and then the parsecs don't need it anymore. So you need to use this redshift, and it's just a series of managing units in astrophysics is a lot of fun. It's
Yeah.
its own special giggle, I think.
Yeah.
But speaking of space telescopes, astronomers using the Hubble Space Telescope have observed. We mentioned this comet earlier, 3I Atlas, only the third known object from outside our solar system to visit our neighborhood. Um, and yeah, I know there's been some press about this. It looks like a comet. It's not a spacecraft. Okay, 3I Atlas is clearly an active comet. It's at 3.8 astronomical units from the sun. It's got a dust. It's got a coma and it's got a dust trail coming away from the sun-facing side of the nucleus, and there's a weak radiation pressure tail, swept tail from the sun. The object is releasing streams of particles, and that's actually really important because we can look at that and use a spectrograph to figure out what it's made of. So we're actually getting an opportunity to study material that originated in another star system entirely. And with Hubble's exceptional resolution, a team led by David Jewett from UCLA was able to determine how much material 3I Atlas is losing as it heats up. They calculated it as a mass loss of about 6 to 60 kilograms a second, depending on the size of the dust particles being ejected. So that's equivalent to losing a small car every few minutes. It's a significant amount for a distant small object. They were also able to uh, determine the size of 3I Atlas, and this proved challenging because they can only see the glowing cloud of dust surrounding it, not the nucleus directly. Although maybe, if we're lucky, might get an idea of what that's like from Mars Reconnaissance Orbiter. But by analyzing the brightness distribution of the surrounding coma, they estimated the nucleus has an effective radius of less than 2.8 kilometers, assuming that it only reflects 4% of the light that hits it. So it's kind of similar to charcoal. But we've looked at other comets in the solar system, and that would be kind of consistent. But really one of the most fascinating aspects of this exercise is we're getting to study, you know, interstellar objects, and that may help us understand where they came from. And discovering interstellar visitors like 3I Atlas, that's extraordinarily rare. But, and before this object, only two others have been confirmed. But with new tools like Vera Rubin coming online, it's likely we're going to discover more, many more. And there are some ideas out there for flyby missions, and that would be very cool if one of them could happen before too very long. So I think that covers kind of the news aspect, but let's talk a bit about the night sky, Suna. You were going to talk about some things that are going on. We're both going to talk about some things that are going on in the night sky this month.
Yeah, there's a lot of interesting stuff happening, including tomorrow morning. So if you are willing to either stay up all night like I do, or get up very, very early in the morning, about an hour or so before sunrise, if you look towards the eastern part of the sky, you'll get a nice treat of Jupiter and Venus right beside each other. Venus is the brighter one, Jupiter is the kind of dimmer one right beside it. They'll be in what's called conjunction, where they just get very close together in the night sky. In particular, in this case, they'll be only 0.9 degrees apart from the sky, so practically on top of each other from the perspective of different planetary positions in the sky. Overnight, another thing to keep an eye out for is kind of overnight tonight, but particularly important is overnight tomorrow night. is the peak of what the Perseid meteor shower. So these have meteors that are coming from the tail of comet Swift-Tuttle. When the Earth passes through that sort of debris field from the comet, you get a whole bunch of these tiny little meteors that end up hitting the Earth's atmosphere, burning up in it, and creating these really cool, like bright streaks of light or shooting stars throughout the sky. So if you are looking to do some observing overnight tonight and even in the next couple of days, go out sometime around midnight, well after sunset, as far away from any kind of light pollution as you can get, and just sort of look up and enjoy the show from the Perseid meteor shower. The best way to do this is to actually just bring like some sort of like a beach chair or a beach blanket or something, so you can actually lay back and look up at the sky and not hurt your neck for standing there for a while watching the meteor shower, and just kind of keep an eye out for bright meteors kind of streaking across the sky. You're going to want to look in the direction of the constellation Perseus, which is nearby to the constellations Cassiopeia and Andromeda. Those are kind of easier to identify than Perseus, I find. But that's just because the radiant point of the meteor shower is in the constellation Perseus. So most of the meteors in the Perseid meteor shower are going to be coming from that direction. And then once you're done watching the meteor shower, just keep an eye out for Venus and Jupiter in the morning at around sunrise. You don't need any sort of telescopes or binoculars or anything to see any of these events. You can see it all with the naked eye. But if you do manage to get your hands on a pair of binoculars or a small telescope, definitely point them at Jupiter and Venus. The moons around Jupiter are pretty bright, so you can sometimes see them even through small binoculars. And Venus is also pretty interesting because it has phases like the moon. So you might actually be able to make out a small phase on the planet Venus. It won't look like a perfectly circular disk like other planets like Jupiter would, for example. So definitely a couple of interesting things to do in the coming days.
Yeah, summer observing is my favorite time, and insect bites on my arms and legs aside, I love doing it. And the planets are becoming a story if you stay up late or get up early. But if you want to stargaze, I mean, just looking east after it gets dark, if you've got dark skies, you're going to see a bunch of Messier objects, easy to recognize summer constellations, and so on. This is a super time to go to a dark sky preserve or even a star party. They're here in Southern Ontario. Starfest 2025 is running from the 21st to the 24th in Ayton, Ontario, and you can look it up online. We also have events at the AICO. Those are worth joining. But you get a lot of publicity about this, and unfortunately, as with many things in social media, try to be cautious about stories about planetary alignments. The planets do align a little bit. That's really a thing of orbital mechanics more than anything else. And it's visual. It doesn't have any specific significance other than what you see. But I saw a post the other day talking about the fact that Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune would all line up later this month and be visible to the naked eye. Well, as with a lot of stuff, yes and no. It's true that later this month, like tomorrow, you're going to be able to see, Venus and I think the moon and as Suna mentioned, Jupiter's in the sky as well. Saturn's there. But they're spread over a bit of an area, okay? So the phase alignment doesn't really mean that much. And to me, it always reeks of astrology. But if you look later this month, you're going to be able to see the moon, Venus, and Jupiter pretty easily, okay? But Saturn's there too, and if you know what you're looking for, you'll see it. It's brightish, but there's stars around it that are pretty bright too. Neptune is not visible to the naked eye, full stop. You can't do it. Uranus might be visible to the naked eye under ideal conditions, but the fact that the moon is there means those conditions aren't ideal, so you can't. And Mercury, hard to see. It's really close to the horizon. So again, the universe is beautiful. And if you go out and observe, the night sky is full of wonders, but you don't need a special alignment, which comes only every number of X years, and to see these wonders. Get a deck chair, as Suna said, grab a pair of binoculars, get out there and enjoy the night sky. Don't forget your bug spray. And with that being said, we're at time. So You've been listening to York University Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Suna Withers and myself, Paul Mackin. This podcast and past episodes are available wherever podcasts are distributed. You can always connect with us on Instagram at the handle at York U Observatory on Facebook at Allan I Carswell Ob. Our website is yorku.ca/science/observatory, and there we have a lot of interesting content. And if you feel so inclined, it's a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. On behalf of Suna and I'd like to say thank you for tuning in this evening. We wish you clear skies and a great night.
Have a good night.